Alrighty, welcome everyone to day 4 of Advent Decode. Time is coming up here shortly where the problem will be released. Hopefully today's goes better than yesterday's. Yesterday's was a bit rough on the second part. Hopefully I can actually read correctly and pick up the problem that it's asking. But base code set up, we got our file here ready for input in. This is set up. If I run it, I'm assuming it's running day 4. Let's just verify real quick. But yeah, looks good. So everything's set up. A few more seconds until the problem is released, and then we will get started. Alrighty, here we go. 3, 2, 1, day 4. Let's see what we got here. This looks fun. Drop it in there. This might be an interesting time. All right. You're already almost 1.5 kilometers, about a mile below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that's attached itself to the outside of your submarine. Maybe it's time to play bingo. All right. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random. The chosen number is marked on all boards at which it appears. May not appear on all boards. Yeah, it's bingo. The submarine is a bingo subsystem to help passengers currently using the giant squid pass the time. It automatically generates a random order which to draw numbers in a random set of boards, your puzzle inputs. After the first 5 numbers are drawn, 7, as is this one, okay, there are no winners, but the boards are marked as follows, shown here adjacent. 24 is drawn, and we have a winner here. The score of the winning board can be calculated. Start by finding the sum of all the unmarked numbers on the board. In this case, the sum is 188. Then multiply that by the sum. Multiply that sum by the number that was just called when the board was once 24. So we gotta figure out which board's gonna win. Okay, fair enough. So the first line, so this is gonna be interesting to parse out. So we're gonna start by just grabbing the. We're gonna do this in a string array. This is going to be the inputs, not inputs. This is going to be the random numbers. Call that. And it's going to be inputs get 0, and then we're going to go ahead and split on the commas is what it needs to be. Okay, so that should give us all the random numbers. I could go ahead and split and then convert them to numbers, but this is fine for now. I think we're going to be running with strings anyways. Okay. And then from there, we are going to have to then read through all the lines, generate all the boards, connect them, and then we're going to have to do kind of a system to calculate whether or not they are there. So we're going to need a list of int arrays, a 2-dimensional int array, that way it's the boards. So here are the boards. Array list, whoops. So this is going to be all of our boards. And then we are going to have to best way to read this in. Well, I think what's the best way to read these in, because they're gonna be 5. Obviously that's not that bad. We can split the lines to just knowing how to grab each board. Let's do this. Let's do first, I'm just gonna say the first line is 3. So what we can do is we can do or no. Then we're gonna need an int current line equals whatever. This is gonna no, this is fine. This is fine. So while the current line is less than the input.length, I'm trying to figure this out in my head. Input.size. So we're going to go through and we're kind of grab each line of the boards individually and just do the first line, second line, third. We're going to do it this way. It's the best way. I mean, there's probably a slightly better way, but this is just how I'm going to do it. And then we're going to do this, and then at the end we're going to do current line plus equals how many? So we're on 3 plus 6. Okay, the first line bit's kind of whatever. Oh, we're gonna do this 5 times. While I is less than 5, I plus plus. This will grab us all the 5 lines. That's what's missing. That's why I need this first line here. Because every time we're going to set current line to this plus I. There we go. Okay, and then from here, now we can then go ahead and do boards dot. This is going to initialize them as empty, which is a problem. So what we're going to have to do is first check if I is 0, so this is the first line. We're going to have to go ahead and generate these boards. So we're going to do here's our double int array. This is the individual board. We're going to have to do board is a new int array. It's a 5 by 5. And then we're going to have to go ahead and do boards add board. Otherwise, we need to grab the board. And we're going to do this by getting... we can get the index from the current line, can't we? So we can do current line minus I minus I minus first line divided by 6, I think. Will that get it to us? That's gonna be a question, but we'll test this here. I don't know, this math might be wrong. Either way, now we have the board. And we can go and do is we can just do board. Actually, let's just do this first. Let's make sure this works, and we're gonna do the line is going to be the current line, so it's going to be input get current line. Let's go and just split on spaces because that's what's delimiting. No, we can't split on spaces because single numbers like this don't work like that. So we gotta grab every 2 numbers. Okay. Seems to be J. J is 0. This has gotta be a slow way to do it, but this is fine. This is not the fastest way. I can already tell it right now. J is less than 5. J plus plus. Num is going to be okay. The number is going to be line. It's going to be integer parseInt line substring from j times 2 to j times 2 plus 2. And let's just go ahead and just strip out any spaces. That should give us our number. And now we should be able to go ahead and do board of row, which is going to be I, column, which is going to be j, and this will be equal to this number. All right, let's just see if this gives us any errors. It does. Oh. Oh. There's a space. Times 3 plus 2. My bad. Oh. Yeah, but I didn't change this one. Huh. There we go. Okay. So it is working. So we're good now. Okay. So now we've got all our boards loaded. So now that they're all loaded, we can go through the random numbers. We need to go through and num and random numbers. Go through and kind of add these to the board and calculate somehow if they've won. Well, then now we get the issue of I just did an integer array. I have no way to know if these were valid or if these been guessed. Well, we only need the last one. So actually we could just mark them down to a -1. That's something we could do. It's probably gonna come back to bite me, but let's try that. So now we're gonna go through each board in boards, and we're gonna have to go through and check if they, and then we're gonna have to go through and check again to make sure or find any matches. This one's just long. It's not, I wouldn't say partially hard, it's just long. But we need to keep track of the last number. Okay, oh, row is less than 5, row plus plus. This one's just gonna be long. I feel like I'm doing something wrong here, but again, I just go with what I come up with first in my head. So if board row column is equal to last number, we can go ahead and set this equal to -1, mark that it's been obtained, I guess. And then after this, we need to now check for winning boards. Which is to go through, now we have the various ways to win, which is going to be straight across, down, or diagonal. And there's the 2 diagonals. Go through each row. So Boolean 1 is false. And then we just go here and check if it's -1. Or if it's not -1, sorry, when is true. This will go through each row and check all of the across. Sorry, if it is not -1, go ahead, set 1 to false, and then go ahead and break out because it's not 1. And then the win is adding up all of the 1 boards. Okay, and so we're going to need then to store the board winner. So that means that this is 1, so maybe just have board winner equal to board, and we can probably break also out of here. And then same thing here, if 1, just break. All right, so that'll set our board winner, and that'll work for all of the rows. And now we can also go across, and we can switch these up to do columns here now. So now checking the ups and downs. And then now we just gotta lastly check, probably manually, the diagonals. So if row 0 oops, I mean, okay. 1 1 2 2 3 3. It's yeah, this is fine. Then we have, if this is all true, we now have a winner, and we can set, we could set 1 to true, but that's kind of irrelevant. Oh, we need to reset 1 to true here. That's why it's complaining. We don't need to care about 1. Okay, so there's that one, and now we just need to go the opposite way, which is going to be row 0, 4, 1, 3, 2, 2, 1, 0. Okay. I guess we could also go ahead and we should probably also actually also set 1 here as well. 1 is true. 1 is true. And if it's a win, actually we don't need to do, we can just break. And then last but not least, so now we have a winning board. This is all really long. But now that we have a winning board, we can go through the board here. Let's copy this. And this is the board winner. If it is not equal to 1, we now need a long, this is going to be the leftover, I guess, is what it's going to be called. And we're just going to do, oh, we need to check first if 1, then we do this. So therefore, well, I mean, 1 kind of means that board winner is not null, but this is fine. So I said to, I can't do, yeah, do null. Okay. And then this is the case. We then do this, and in theory, then we just do a lap of left over. Whoops, which goes here. And we have to multiply it by last number. Let's see if this even works. I don't know. I could have gotten this right. Nope. Multiple boards won somehow. Oh, hold on. And then break out of this, so we only get 1 board. Okay, this doesn't seem like it's gonna be right, but I'm not going to have it into code for some reason. No. Okay. Let's put the sample input in. Let's see. So this one should be 188 and 24. Okay, so let's do. $69 and 22, that's not right. Oh, hang on. This win isn't being reset to true every time this goes. It is checking every row. That would be a problem. You should be resetting win to true every time. $188, 24. Oh, hey, we got it. Okay, so that was it. Okay. Let's retry with our answer now. Hey, we got the first one. Nice. Continue to part 2. On the other hand, it might be very wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo game boards this giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board. Okay, so we need to find which board will win last. Once it wins, what should the final score be? So same thing, just find the last board to win. Okay. Luckily, we have done a majority of the work here in calculating this. So I'm going to just clean this up a bit more, condense the code a bit down. Okay. We're gonna have to break some stuff into function here. Public. I need to break some stuff up into function that way I can do this multiple times. Let's break this. So we need a public list int array. We need a way to gender boards. If not, it's not JavaScript. This is not JavaScript. I keep trying to do JavaScript here. All right. List. Too many programming languages at once. Input. Nope. Input. Okay. And then here return boards. Okay. And then up here, list of the said boards will be now generated. Okay. This is all we should need to do to get us into part 2. It's going to be a long thing here, but this is fine. Copy paste code for the win. And so all we care about here is now if it's 1, we need to check for wins here. And instead, if it's 1 and wins is equal to boards.size, we go through this. Actually, no, sorry. Yes on this, but now only if this is true do we actually then go through this final step. Otherwise, well, we always increase wins. So if I'm right, this should now work and give us our second one, please. This does need to be done like this. Get K. This one's not, yeah, this isn't good for me today. This is not my best work. Let me go with that. While K is less than. There has to be some like faster way that I'm just missing with this. There's like, I have to be like missing like the more efficient solution or something. I feel like I'm just not doing this correctly, but well, I mean, I'm doing it correctly, I guess, in the end, just not, I think it is. Okay. And then, so now if we win, now instead of board winner, well, board winner should only be set though technically like this. So technically in that case, if we get to here, board winner does not equal null, technically we should break here. The win's not going to be correct, I don't think. We can just do this. I don't know if this is going to work right. Oh, it did, 148.13. It did work. Okay, so that does fix it. Back to ours. Please be right. Hey, we finished it. Okay, so actually I took the liberty of going through and cleaning up my code a lot for this. Made this not more efficient, but just much easier to look at and to comprehend what is happening. How I did it before, it just was bad. I should have broken things off into methods way earlier, but at any rate, let's go through this question. Let me explain how I got to my answer, what my now answer is actually doing. So TLDR of this question is basically you're playing bingo. The first part, you need to figure out which card of your bingo cards you have, which is your input, which of those wins first. To do that, the first thing we do is read the first line of our input. That is all the random numbers that are given, basically the order in which the numbers on the bingo card are called out. And then from there, we need to then generate all the boards from our input. Our input, it looks like this. Here's a card, here's a card, here's a card. And from these, we need to generate the boards out of this and store them into data. I broke this off into a method. Now this method handles that whole process. The way I do it is I basically go line by line of each board at a time. So I do the first line of every board all at once. I do this first line, first line, first line, first line, and then I go to the second lines of all the boards and add them in, and third lines and fourth and then fifth lines of all the boards. I do that just because I can understand the math a little bit better on how that works. But anyway, this method here will go through all those, pick all those lines out, and save them into this boards list, which will end up getting returned. And then from that, we now go through the process of going through all the random numbers and putting them onto the board. So we have this for loop here that would go through all the random numbers. First thing it'll do is we'll parse the number out, and then it'll go through all the boards and actually mark that space on the board as it's been called for bingo. I do this by marking that as a -1. -1 in the two-dimensional array for me signifies that that number has been called and has been marked. I'm allowed to get away with this because we don't need those numbers anymore. Whatever, I do store the last number, but that's all I really need. After that though, this is where things get a lot cleaner. I go through all the boards and then I check if the board has won. I moved all the winning logic off to this one method. This is much cleaner now. It'll first go through the horizontal rows. It'll check all the horizontals to see if any of those have won. If not, it'll then check the verticals. If any of the verticals have, if you've won vertical on any of the boards, and last it'll check the two diagonals and return whether or not either the diagonals have won. For part 1 here, here we are. If any of the boards have won, it'll return, it'll save that winning board. It'll break out of this loop here of checking all the boards for a winner, and then it'll do our logic here to then output the winner, output what it needs, which is to add up all of the remaining unmarked spaces and then multiply that by the number that was just called, or in this case the last number. I probably don't need to do this in this fashion anymore. I could probably just get away with actually just doing number here, and it would probably all work just the same. So yeah, and then we can now get to part 2, which I'll also have to switch over to this number system here real quick. All right, anyways, then for part 2 is the same as part 1, but instead of finding the very first board that wins, we want to find the very last board that wins. To do this, we do the exact same thing, go through all of the, we generate the boards first, then we go through all of the random numbers that are to mark on the boards, and then we start off by then, again, marking those boards for that number. After that, we then go through the same process of then checking if a board is won. This time, if a board wins, what we will go ahead and do is remove said board. We don't care about the board anymore, we don't want to do any more logic with it, just remove it from our list and ignore it. We then keep doing this process until we remove a board or until we get a board that's won and it's the last board to win. In this case, the board's list here is a size of 1, meaning it's the last board and it is now 1. Because of that, we then do again our logic here to calculate how the sum up all the numbers that have not been marked off on the board, and then multiply it by the number that was just called, and that is part 2. And this code looks infinitely better than it did when I did this the first time around. Let me just say I am much happier with how this is looking. I like to do these single lines just because it condenses a little bit more. I like it, but it's totally not needed. But at any rate, took me a while to get here. It did not look good through the whole way, but now that it's done, it looks much better. I don't know if there's a more efficient way to do this, but this is what I got. But at any rate, that is day 4, done and complete. Hopefully you guys enjoyed. I'll see you guys all tomorrow for day 5. Peace out.